Hey, what's up everybody? It's your boy Yousuf, and today we're building this entire GNS3 network topology right here using Python and the requests library. No clicking, no drag and drop, no manual setup, pure code. And at the end, I'm gonna show you something crazy. I'm gonna ask Claude AI to modify this topology live. So let's go. Look at that R1, R2, R3, three switches, six PCs, all linked up, built in seconds with pure Python. Now, if you already know Python and GNS3 and you just want the file, link is in the description. Go to my GitHub repo, download it. It's completely for free. Enjoy. But if you want to understand the code and then implement it yourself, let's dive into it. Alright, so let's break down this code line by line. Don't worry, it's simpler than it looks. First two line, we define our GNS3 server. Localhost port 3080. This is usually the same for everyone because the GNS3 always runs on your local machine on port 3080 by default, so you most likely don't need to change this at all. Then we define auth, your username and password token. Now this one might be different for you. To find it, go to drive C, users, your username, app data, roaming, GNS3, and open the folder 2.2. Open this file with VS Code, and right there you'll see your username and password. If you don't see a username and password, it means auth is not enabled in your GNS3, and you can just remove the auth parameter from the requests completely. But if you do see it, copy paste them right here and you're good to go. Now these two functions, getJSON and postJSON, that's it. That's all we need. GetJSON sends a GET request to GNS3 API and return the response as JSON. PostJSON sends a post request with a payload. Every single thing we do, creating routers, switches, links, uses these two functions. Simple. Now this is important. GNS3 has templates. These are basically blueprints for your devices. We call get slash v2 slash templates to get all available templates on your GNS3. Then we use this find lambda function to search by name. So router underscore TPL find the C7200 template. Switch underscore TPL finds the Ethernet switch. PC underscore TPL finds VPCS, which are our virtual PCs. And we grab the image name from the router template. This is the actual Cisco IOS image file GNS3 will use. Now keep in mind you have to have a router image installed in your GNS3 for this to work. We're using the C7200 iOS image here. If you don't have it installed or you don't know how to get it, send me a message on Twitter or LinkedIn or just drop a comment below this video and I'll send you the instructions personally. But this script will not work without iOS image. That's non-negotiable. And one more thing, make sure your router name in the code matches exactly what you have installed in GNS3. If your template is called something slightly different, the script won't find it and it will crash, so double check that. Now we handle the project. First thing, make sure GNS3 is open and running on your machine. That's it. That's all you need. When GNS3 is open, it automatically runs the local server on localhost port 3080. And that's what it allows us to send our get and post requests. Now we get all existing projects and check if our project called tests already exists. And the reason we do this reuse check is simple. If you run this script twice and the project already exists, GNS3 will throw a 400 error saying the project name is already taken. So instead of crushing, we just grab the existing project ID, and keep going. Smart and clean. Now the fun part. Three functions: create router, create switch, create PC. Each one called post slash v2 slash projects slash project ID nodes with device details. Look at create router. We pass the template ID so GNS3 know which blueprint to use. Node type is Dynamaps because C7200 is a Dynamaps router. Compute ID is local, meaning it runs on your machine. And inside properties, we define the platform, the iOS image, RAM, and the slots. These are the interface cards on the router. Slots gives us the fast Ethernet interfaces we need for connection. For switches and PCs, it's simpler. No properties needed, just simple ID and not type. Now we actually build it. We create R1, R2, R3 at different X and Y positions. That's just where they appear on the GNS3 canvas. Then switch 1, switch 2, switch 3 below them, then 6 PCs at the bottom. Each function returns the node object from GNS3, which contains the node ID we need for linking. Last part, links. The link function takes two nodes and connects them. The adapter number is which interface card, port number is which port on that card. R1 to SW1 uses adapter 0, but R1 to R2 uses adapter 1 on both sides because adapter 0 is already used for the switch connection. If you use the same adapter twice, you get a port conflict error. Then we continue using the same method to connect the switch to the PCs. Now this is where things get interesting. We're going to move into Claude code, and I'll show you exactly what's going to happen. So notice I'm on a free plan right now, and what I'm going to do is to take the code from Visual Studio Code, copy it, and paste it into Claude code. Then we're going to modify it. We'll add two more routers using switches, same style, just extended. We'll also connect switches and PCs to them. So let me write the prompt. Connect it. Then, so there you go. We have the code, and now I'm gonna copy and paste the code into Visual Studio Code. Notice that you only need to modify the last part where we add routers, switch, and computers. So there you go. Oops. All right. So notice that there are some few errors popping out. Just that's because of the fact that Claude only add things, and I'm gonna have to manually copy paste it. So you can also just write another prompt and say that give me a full correction. So that will also work, and it's pretty easy. But I choose to not to do that because I want to show to you that with only one single prompt you can do that, but you'll also have to understand the code basically. So let me copy and paste everything. Now let me copy and paste the code for the router to connect all the routers, and then for PC section is at the very end, and I'm not going to include the parenthesis status because that's just for visual output. It is not necessary for the actual topology. So to keep this organized, I'm going to change the project name so we don't override anything. I'll name it AI generated topology. So now let me run the code, and we get an error. Just that's because that I installed a request model in a different Python environment, so it's really easy to solve it. Select Control plus Shift plus P, and then select the interpreter and then choose your Python environment that you install it, and make sure you install the request model uh, correctly. I installed it before, that's why I didn't show you. But to install it, just write in your terminal pipe install request, and you can install it. Let me just open the GNS3 project, and there you go. This is our topology that has successfully added the 2 extra routers just like we wanted. Simple as that. At this point, you can basically extend it however you want. You can even start the routers and run the project. It may take a few moments to boot up, but eventually it will work. And there you go. You can see the original devices running, and the full network topology is working. And that's it. That's how simple it is. Thanks for watching, and I hope you learned something useful, and take care.